by giving out research grants, recognitions, and prizes during different CSP events. In the next slide, we also awarded an all girls team in a national programming competition. It's a unique scenario to behold when you have a team of all girls. So we gave out a token of prizes for them. So in these events, we also host talks where conversations with role models have been part of the program of activities. So in the next slide, yes, so we network, we incentivize, and we continue the conversations with role models. In the next slide, we hosted the Inspired Conversations with the Filipina CEO Circle or the FCC in 2019. And we also host a regular monthly event called Virtual Meetups, where we invite prominent women in technology, where they share their experiences as women in technology, um, and how they persisted in their field of technology. So please allow me to end my talk with a quote from Miss Cristina Concepcion, the FCC president in 2016. It's about fulfilling who you are as a person. If you want more, then go for it. Don't let convention or other people stop you. End of quote. So that will be the end of my presentation. Thank you. I hope you learned something from me today. If you want to get in touch with us, this is my email. And if you want to see the events that we've been hosting, you can check my website. Thank you.
Thank you so much, Dr. Rojas. So Dr. Rojas is part of our in our panel discussion later as well. So we will be able to answer your questions related to her presentation later. Thank you. All right. So the next speaker was the presenter and best paper research in computer science. He is an awardee in the fifth Y4IT Research Summit. He is here today to talk about an AI-assisted diagnostic tool in the form of a web application which can detect pneumonia from X-ray images. Let us all welcome Mr. Ralph Joseph Tegueran.
Okay, so good morning, everyone. I'm Ralph Legaran from the Asian Institute of Computer Studies, and I am the author and presenter of our bachelor's thesis and the research paper entitled Applied Computer Vision on Two-Dimensional Lung X-ray Images for Assisted Medical Diagnosis of Pneumonia. So our research paper is the awardee of the Best Paper Presentation in Computer Science in the last Y4IT Research Summit. And I was invited here as a guest speaker to present our research paper once again. Okay. So before we start, I would like to give credit to my research team and co-authors, Manuel Valencia, Vince Fernandez, Lucky Aquino, and Angelo Chuakay. And also a lot of thanks to our research and his advisor, Professor Manuel Luis de los Santos. Okay, so here's our certificate of recognition. So if you're a fourth year computer science student, I actually recommend you join the Y4IT Research Summit because you will be exposed not only to research, but also to cutting edge computer science concepts such as artificial intelligence, Internet of Things, machine learning, and data analytics. And overall, it's a great experience. Now, so introduction. So I will be discussing the three important motivations that led to our research. The first one is the slow but gradual application of artificially intelligent computational tools in medicine. So even though it is not yet in mainstream and still an experimental stage, artificial intelligence has been used in medicine in order to assist doctors in the diagnosis of diseases. There are several companies, usually in the United States, that they conduct machine learning on medical data in order to predict possible illnesses on patients. And the second one is cases of medical misdiagnoses of pneumonia. So this actually happened in impoverished regions of the world, such as, based on our research, we were able to gather cases of medical misdiagnosis in Vietnam and Nigeria. And the third one, I think this is the most important, is the use of X-rays as preliminary diagnostic tools in the detection of COVID-19 prior to the widespread implementation of nasal swab testing. So before nasal swab testing became mainstream, COVID-19 was actually detected using X-rays. They were able to differentiate normal pneumonia from COVID pneumonia through X-rays. Okay, now research overview. So what does our research actually deals about? It deals with the development of a free-to-use web-based application that can detect pneumonia from 2D X-ray images using Python-based Flash framework. So a Flash framework is a web framework that uses Python code. The next one is the implementation of a convolutional neural network algorithm for the web application and the utilization of open source datasets to train the neural network. So later, I will be discussing CNN and dataset and machine learning. So what is the significance of this? It can be used by medical practitioners for the assisted medical diagnosis of pneumonia. Such as I've mentioned earlier, there are cases of misdiagnosis. So this can enhance the accuracy of diagnosis of medical practitioners. And the second one is it can be used by biomedical informatics researchers as an experimental tool. So biomedical informatics is a research field which combines computer science and healthcare and deals with the analysis of medical data for useful medical applications. And the third one is can be used by computer science researchers whose area of research interest is in the field of machine learning and artificial intelligence. Okay, so proceed to the methodology. So we'll be discussing about the basis of the algorithm, which is convolution. So in matrix theory, convolution is defined as the recursive dot product between two matrices. So if you're taking up matrix theory or discrete mathematics and computer science, matrices are actually collection of values arranged in rows and columns. So if we have two matrices A and B, and we did a recursive dot product between those two matrices, that operation is called a convolution. And it's important to note that matrix B is considered as the kernel matrix. So if you're going to ask the question, why is matrix important in computer vision? That's because images are actually matrices. Since digital images are composed of pixels, each pixel we can assign a value of 0 to any number to a pixel. And then once we have assigned that value, as you can see in the right image, this is actually the matrix representation of the digital image. So the digital images are technically matrices. Now we'll be discussing about deep neural network. So a deep neural network is a type of artificial neural network. An artificial neural network is a software or hardware implementation that attempts to replicate the operation and structure of a natural or organic neural network, which is the human brain. So there are actually two types of neural network, the simple neural network and the deep neural network. The differences between these two is that a simple neural network consists of only one hidden layer, and a deep neural network is composed of multiple hidden layers. So in our research, we actually dealt with deep neural networks. Okay, so this is the specific type of deep neural network that we've dealt with, the convolutional neural network. So the convolutional stage, pooling and fully connected are the hidden layers. So as you can see, the convolution which as I've discussed earlier is the mathematical operation between matrices. So that's actually the core of the algorithm. And then the pooling, which is an attempt to minimize the matrix after the convolution. Fully connected layer and is a preparation for the output layer. So what kind of specific CNN algorithm did we dealt with? It's the Vgg16 algorithm created by Karen Simonian and Andrew Litherman from the Visual Geometry Group from the University of Oxford. So this type of neural network consists of 5 feature extraction layers, a dense layer, flattened layer, and output layer. So specifically, each block feature extraction layers, block 1 and 2 are actually composed of 2 conv2d and 1 max pooling 2d, which is conv2d is actually a computational function in Python that executes convolution on matrices. And a max pooling 2d is a computational function that executes a pooling function on the matrices. And feature extraction layer block 3, 4, and 5 are composed of 3 convolutional layers and 1 max pooling layer. Okay, so in order to train our neural network, we need to execute a machine learning process, which is referred to as transfer learning. So transfer learning can be thought of some kind of combination between supervised and unsupervised machine learning. An unsupervised machine learning is when the developer allows the program to analyze a set of data without intervention. And a supervised machine learning is when the developer prepares the data, classifies the data, and then feeds it into the machine learning application. So transfer learning is somehow of a combination between those two, in which a well-prepared data set is used. And then during operational phases, the algorithm learns as it operates. So as stated here, learning of new tasks relies on previously learned tasks, and learning process can be faster, more accurate, and or need less training data. Okay, so a description of the data set. So we've obtained the dataset from Kaggle, an open and online community for machine learning and data analytics. The dataset is entitled Just X-ray Images for Pneumonia Detection with Deep Learning, published by Tolga Dinser, a data scientist from the United States. It is composed of 5,856 X-ray images, reclassified as mnemonic and normal, organized to training and test groups. Okay, now here's a screenshot of our dataset. So it's composed of around 5,000, approximately 5,000, and divided into normal and mnemonic groups. Okay, now here's the algorithm implementation and our web application system architecture. So the algorithm during machine learning outputs the knowledge base, which is an H5 file. This contains the kernel matrix or the patterns that were gathered from the machine learning. And then during operational phases, that knowledge base is feedback into the system in order to diagnose images as either mnemonic or non-mnemonic. And for the systems architecture, it's actually a traditional type of architecture, which is composed of the front end, the back end, and the cloud storage. So here's a screenshot of the machine learning. So we have done the machine learning in Linux, but it can be done on Windows and any other or Macintosh. It approximately takes around 4 hours to generate the H5 files. So, but that depends on the hardware of your machine. If you're using a high-end machine, it will be a lot faster. And here's the screenshot of our developed web application. So I think it would be better if I show you the actual web application. So here it is. So we've created this web application. It's called Roentgen Engine Analysis, named after the physicist Wilhelm Conrad Roentgen, the discoverer of X-ray. So this is the front page of the web application. Here's the machine learning, which is we created this web application to be somehow self-documenting. That you can there are parts here that you can read, so you can understand what the web application is about and how to use it. So this is about the machine learning. So here's our results. And the concept of extended intelligence, which is actually deals with the augmentation of human intelligence using AI. So this is actually our focus is not to replace humans, but to use artificial intelligence to augment the capabilities of humans. And the credit page, which is our the developers and the authors. And I think it would be nice to demonstrate the actual operation. So if you scroll down, there's this choose files button. So if you click that, and here are our X-ray images. So you can select all of them and press submit. So